Hi, so this is Charlie. So I've worked some more on the bouncing off the walls issue, and now, so here we are in the game, and now you can see as you come along the walls, you tend not to get, not to be able to go through them. Okay, so we've got fairly good ability not to go through the walls here, and you can't get through in the corners or any of the places. It pretty much keeps you from going through the walls. So here's what it looks like. If we come over here and we go to collisions, and here's our method that detects whether there's collisions or not. And then as you can see, we iterate through our rays. So we look at all those different directions. We look north, we look northeast, we look east, we look southeast, we look south, we look southwest, we look west, we look northwest, and then back up to north again. So we look at each of the different directions in turn. And if at any point we get a hit, we push it into an array of hits. So we know which directions it was when we got hit. So if our array hit's length is larger than 0, in other words, if we got a hit, then we send out some debug information, and then we call bounce away. And bounce away checks to see if we got a hit in more than one direction. If we only got a hit in one direction, then it's fairly simple, but sometimes you get a hit in more than one direction. And if we do, we get the average of them. And I don't really like this method. It's not very good, but it seems to be safe. It doesn't seem to ever return anything bad if there is an average. And then we go from there, we do the hit choice, and we decide which one actually got hit out of them. And then we call, we do some more debug information. And so suppose the choice was number 1, which would be northeast. Then what we want to do is go southwest. Or if you went north, you want to go south. Or if the place where you hit was northwest, then you want to go southeast. And if there was more than one choice, we choose the average of the three. So suppose it returned you hit in the north, you hit in the northeast, and you hit in the east. Then what you want to get is the average of them, which would be in the northeast. And that's what this average is designed to do, is to give you the average one. And then whichever one it was, we add 3 to it. And then if so, suppose the choice was 7 and you added 3 to it, then it would become 10, and then you get the modulus of 10, which would take you back to 3, which is the opposite of 7. So whatever we do, we try to get the opposite direction. This is the one that if you're going north, choose south. If you're going northeast, go southwest. Then we do some debug information, and then we simply move in the direction that we want to go. Now, what I'm choosing is the ray and its distance, and the rays are always set to 1, and that can be too big a bounce for us in our game. So sometimes I divide the bounce to make it smaller so that instead of 1, it would be 0.1 or something like that, depending on what you want to set bounce to. And then the actual move does nothing more than move you to that new position. So as is so often the case, once you understand how to do it, it's simple. Let's take the debug out of there for just 1 second. And when you take the debug information out, it's really only, actually this line, it could be pushed into here, so it would end up becoming 1, 2, 3, 4, 5, 6, 7, about 10 lines of code, which is pretty good. And that's all I wanted to say. So you should put this in your homework, I guess, by giving you the video. I'm solving the problem for you, but at least you'll have to make it work yourself, which is good. And then over in controls, I'm not doing anything different than we were doing before. I check for colliding in the NPC, and then I just call this method the over here. I do set is on object to false in my animate method, and that I haven't checked it just recently, but that seems to be an important part of it. Oh yeah, there is one other part of it that's really important, and that's the in pointer lock itself. This was my final and most frustrating bug. I can't believe I was forgetting to tell you about it. But in here, in pointer lock controls, you want to make sure, we don't care what's happening in the Y direction because we're not moving, we're only moving in the X and Z direction, but make sure if you're on the object, if you've hit something, that you don't move in the X or the Z direction. Somehow I'd gotten into this for a little bit and it made me just keep moving in the X direction when I moved to the right or in the Z direction when I moved backwards. So if I was heading north and going backwards, it wouldn't stop me from moving north. It would keep me inching just a little tiny bit because it kept this velocity business. So just make it 0. All right, that's all I wanted to show you here on this one. So that's pointer lock controls. All right, thanks now. Have a good day. Bye.